Alright, in this video we're going to sort of recreate some of the behavior you might have seen in video games where you have one character that attacks another and there's a certain amount of hit points. Right? So this is something that you may have seen in almost any video game, even if you're not a big video game person. So we're going to go New File, and I'm going to create a Wizard class. Right? And I'm going to use a capital W for this file name because this file is going to contain a class, and by convention you capitalize that file name and also the class name. So we have class wizard. So remember that classes are basically blueprints for objects, right? This is we can make many wizards. So a class, we can make an object, and we can make many of those objects, many instances. So each one of the objects that we create with this class are going to have the same set of attributes, right? So attributes are things that are attached to this object. Attributes are values, data values attached to the object, but also functions that are attached to the object itself. So first things first, when you create one of these wizard objects, right, we can start by just passing on the implementation. So we're not going to implement anything special with this wizard to start with. And if we run this file directly, main. So this is special syntax that Python uses. So this block of code will only execute if I run this file directly. It won't execute if I import the file. So this is kind of a nice place to do little tests for some of your modules. So here we can say we have a wizard W, and to create one of these wizards we call the class name like that, right? And then left and right parentheses. So we call it just like a function. Alright, and if we were to print this out, we can print out W. We can print out a couple things. Print the type of W, and then we can print, this is a useful Boolean expression, is the type of W, his type is wizard, right? So is the type of this item, oops, that should be a W, the type of this item W, is that a wizard, right? That's what this is saying. So this is kind of useful when we have classes, when we have some data stored in a variable, we can check to see what it is. Is this thing a wizard? Is basically what we're asking this here. Is the type of this thing a wizard object? Right? So we'll look at these few things here. What's the output here? Alright, so Python 3 wizard. Okay, so the first thing, when we just print out the object we created, well, this is the terminal, and so we can only print out string data to the terminal, right? So this is a string representation of this object. So Python knows kind of what scope this object is. So first of all, it uses the angle brackets to designate that this whole thing is an object. And what scope is the object defined in? It's the main part of the program, right? The main scope. And then it's a .wizard object, right? And then this part is the memory location in which this wizard object is stored. Okay, so the OX means a hexadecimal number, right? So each one of these is 4 bits of binary. So that is the memory location where this object is stored. So printing out an object by itself, you're going to get some mess like this, and it uniquely identifies the object kind of here, but that's not particularly useful, right? But so if you see something like this, that just means you printed out an object in Python, right? So that next line, we're printing out the type, right? So what type of object do we have? Well, the type of object we have is a class, and that class is defined in the main scope, and it's wizard, the wizard class, right? And then this last line is going to be kind of useful. We can check to see if the type of the object stored in W is a wizard. And in this case, we see that it is true. So it's nice to be able to check to see if the type of something is one of these wizard objects. All right, so that's kind of a starting point. We're going to comment that out. Now we want to create one of these wizard objects, but we want special properties. So we want to define what properties are attached to our object. So to do that, we need to define an initializer function. Okay, so initializer functions in Python are like constructors in other languages. an initializer, the first parameter of the function is self. This self object represents, the self parameter represents the object itself, the thing that you are creating. So in this case, this will be a wizard, one instance of a wizard. All right. And let's say we want all of our wizards to have a name. Okay, so we're going to pass in a name argument when we create one of these. So this is a name parameter to our function. And we take our object, self. So self is the object that we're creating, right? And we get that here. Python automatically puts this in for us when we call wizard, right? And self dot name, the dot operator is called an accessor. So we're starting with the self object, and we want to access some value associated with that object, some attribute. So name is just an identifier, like another variable, but it's attached specifically to this object. Okay, so name might be a really common variable, but I might have 50 wizard objects, and all of them have a dot name, right? So I need some way to distinguish dot name, or the idea of a name for all 50 of these things. Well, if I have the wizard defined in a variable, that's just one wizard, and I can use the dot accessor to access the name attribute, right? So in this case, we're going to access the dot name attribute, which does not exist yet. So we're creating it right now. In Python, you can dynamically add attributes at any time to an object. So we're just adding the attribute name to our object, self, and setting it equal to this parameter. This parameter could be called anything. It could be called n, right? The attribute name does not need to match the parameter name, but commonly it does. All right, so all we have is we're creating this wizard object, and we're attaching a property .name to it. Okay, so when I create one of these wizard objects now, because I added this parameter, I need to add an argument when I call this, when I instantiate or make an instance of this object. Okay, so my first name here, we might call this Gandalf. All right, so now my wizard has a name Gandalf, and I guess we can move this on down. We don't need these lines anymore. So this self property is provided automatically. Notice I didn't provide one of those arguments. This argument is starting at the second, and I can have any number of arguments here, but they start after this self parameter. So any instance methods you define in the class, so methods that are indented, right? Instance methods you have to define them with this self parameter, and Python will automatically insert that. So let's see how this works. I can say print g.name. Right? So g is my object. That's holding this new wizard that I created. It's an instance of a wizard. Now, I could have lots of different wizards, but this particular one has a name that's different than the other ones. So this name, the .name, is associated with this wizard, G. Okay, so this is g.name, and I can print that out, run the program, and we see g.name is Gandalf. All right, what else am I going to need? So I might need some attack power. I might need health. Right, maybe put health first. And we can set some defaults. So the default health we'll say is 100.0, and we'll say the default attack power is 30.0. All right. Now again, these are parameters, and this is a named parameter, and we're defaulting it to a value. So because I set a default on this parameter, I don't have to include it here. So Gandalf, I'm not going to include either of these, and these default values are going to be used. All right, so self.health equals health. Now remember, these two things are different. We happen to be naming them the same thing. Health here refers to this health parameter, and if I don't provide it, like I don't there, that's going to be 100. All right, and then self.attack power is going to equal attack power. And so now I can print G dot, I already did name, health, and G dot attack power. Right? So I'm just attaching attribute names to my object and then setting values to associate with those attribute names. I can run this. Here we've got Gandalf, and then the health is 100, attack power is 30. Okay, so that's all well and fine. So now I might need some some method of printing out the state of a particular wizard, right? I might want to check in, and whenever you have a character in a video game, you know, there's a health bar and all these different bars, and it shows you the state of these variables, right? Your health is at 100, then you'll see a bar that's filled all the way to the top. We just have a terminal to work with for this case, so we're just going to print out all of the state of our wizard, right? So we'll make a function here called print, and again, this is an instance method of a class, so we have to pass in or define the self parameter on the function. Okay. Now, in the scope of this function, we have to have this object. Now we can reference anything that's already been defined on it. So the init function defined all this stuff on it. Right? That's why we were able to access it with g.attackPower. Right? For a particular wizard, in this case G, this object is stored in this variable G. Right? When I am inside the class, self and then G are synonymous, right? Self is more abstract. Self is talking about the object for any particular wizard, but I'm only ever talking about one specific instance. Okay, so all of these wizards have a name property, right? So self is talking about that particular wizard. So when I run wizard like this, I'm talking about Gandalf, and his name is Gandalf, right? Self is referring to the same object that gets stored here. So when I print self, I might do something like this. We'll have a little format string, and we'll say this is self.name, right? And what this is doing is this is a format string. Inside the curly brackets, you can put Python expression, whatever you type in. So this is self.name, gets converted to a string. That's already a string, but it gets converted to a string if it's not, and injected into the format string. So we're just printing that out, and we're going to print out the rest of the information about our character. So we'll say we need to know his health, and that's going to be self.health. And then we need to know his attack power. Right, and that's going to be self.attack power. Right, so this is kind of a nicer way to print out this stuff. Right, so I can get rid of this. Oops, forgot my parenthesis there. And now I can say g.print. Alright, so now it's important, this G here, self, is going to be this G. When I call print, this is the function that executes, but self changes depending on which wizard I'm using. This is the wizard I created up here. So it's still calling this function, but self refers to all of the data that I attached initially up here. Right, so in this case, the name is going to be Gandalf. And I'll make another wizard in a second, and you'll see the distinction. Okay, so we see the self object was the object here that you used the accessor on, so G dot, and then you accessed the print function. So Python automatically does that for you and puts in that G, that object, into the self parameter. So whenever you see the self parameter, it's that first parameter. You have to define it on instance methods, and Python does that step for you automatically. We don't have to pass in G here, right? It does it for you. So that's why the number of parameters don't match up, because that first one's done automatically. All right, so we have Gandalf, and let's make Merlin. All right, and we'll say that Merlin's health, we'll set that, say he maybe he has lower health. That's like 91. And then his attack power, though, is higher. And we'll say that his attack power is 35. Right? And here, these are just named arguments. They're called keyword arguments. So I'm specifying, if I use named arguments like this, I can flip around the order. So I could say attack power here, and then health could be the third argument, right? So I don't have to use them in this case since I'm already using the same ordering. But when you just see numbers here, it's hard to tell what that's supposed to be. So I like to use the keywords sometimes. It just kind of depends. It's kind of a style thing. All right, so we have Merlin and m.print. So now we have two wizards. So notice the name here is getting attached to this object self. This self is different than the G object up here that we created, right? This is a new object we're creating. So this object now has a name property that's set to Merlin. It has a health property, just like the G object does, but it's going to be set to 91, and it has an attack power, and that's going to be set to 35. All right, so we can print that out. All right, so we've got these two different wizards. All right, so now inevitably in all of these different types of video games you may have seen there, you target somebody and then you attack them, or you strike them, right? And depending, you might have a weapon that has a certain power, and you might have a base power, and there's a multiplier, and you might even have armor that will absorb some of the attack, and whatever attack's left over, that might go through and damage your health. Okay, so that's kind of what we're going for. We're not going to do all that right away. First thing we have to do is just attack, right? So before that even happens, we need to target somebody. So let's start with a target. And we'll say target starts out at none. Okay, but I want to target somebody, so I want to say if self.target, right? We can say if self.target, if this thing we store here is another wizard, right, then we know we can attack it. So what we can do here is we can say if the type of this thing that's stored here, so if the type of that thing is a wizard, then we'll go ahead and print out that the wizard's targeted. Otherwise, we don't have a target. Right, we're gonna say that we don't have a target, right? Because we cannot target anything but wizards in this program, right? So print. We have a format string, target, and self.target.name. Okay. Now, why did we have to do this step here? Well, one of the reasons is self.target starts out at none. Right? So if I access self is the main object. Python looks in memory for an identifier labeled self. There's some memory location. It finds the object at that memory location and brings it back. Then this dot accessor says check that object and see if there's an attribute on it named target. So Python looks that up. Sure enough, there is. And there's some memory location associated with that. So then we grab the item at that memory location. So if we haven't set a target, that's currently going to be none. So this will have evaluated to none. None does not have a dot name. It does not have a name attribute. So we'd get an error if we didn't know for sure that our type had a name attribute. Right? So we're checking to make sure that it does have a name attribute. Basically just because we know wizards have a dot name. And so for our purposes right now, we can only target wizards. Okay, so that's fine. So if self.target is a wizard, then we print out the wizard's name. Otherwise, we'll just print target none. All right, so let's see. We can set a target here. Let's say let's define both of our wizards first. Right. So there's our two wizards, and there's where we print them out. Now we can make a modification here. We can say Gandalf. We can set the target to Merlin, and we'll print this out. So we have set the target to Merlin. So now it's going to check to see if the target is a wizard. And in Gandalf's case, it will be. And we'll see Gandalf's name. Now, Merlin hasn't targeted anybody, so his target should be none. Right, so here's Gandalf. Health is 100, attack is 30, and his target is Merlin. Right? Same properties, or same type of properties, right, for Merlin, but no target there. Now, one thing that you might want to do is, instead of accessing this data directly, the target, a lot of times that's frowned upon, because I could do something like this. I could say Merlin.target, and I could just set it to something that doesn't make any sense at all, right? Target is expecting something that I can attack. It's expecting something that has health, right? And it's something that has a name. But technically I can do this. So I'm going to get, when I print this out, the type of this information is string data, right? So the type of this is str. So this is not a wizard, so this will be false, and I'll still get target none here. But I still don't probably want bad data to be able to be stored here, right? That's probably a bad idea, right? But let's take a look at what we have here, and we can see that Merlin is still targeting none, and that's because of this protection we put it in. We checked to make sure we had a wizard, right? But that protection doesn't actually protect against storing bad data. It might be better if we protected against storing bad data in the first place. So instead of using target, accessing that attribute directly and setting it directly, maybe we want to try to only use a function to do that. And we'll say set target. Right? So this is an instance method, so it starts with self, right? And then we have to include what our target is, right? So this is our target that we want to set. And we can have a check in here that says if the type of this target is a wizard, then we allow it. Self.target equals target. And then we'll return. And then otherwise, we'll print unable to set target. Okay, so if target is not a wizard, it's going to print out unable to set, that should be set target. If target is a wizard, so if the type of target is a class wizard, then we set this wizard's target attribute to this target, which will be another wizard. So this is a little bit confusing if you're not careful, right? So self is one wizard, but it has a property on it called target that will hold another wizard object, right? So right now it's holding none, but self.target, if your target is a wizard, we allow you to set the target property of your wizard to be another wizard. All right, so now instead of setting the attributes directly like this, we're going to say m.setTarget, and if we put in some nonsense like this, it says unable to set target. So it actually protects us from storing bad data. Right? So that's one of the benefits of adding a method here to set one of your attributes. All right, so we don't really want junk in here, right? We want to set the target as Gandalf, right? And then Gandalf g.setTarget is going to be Merlin. Right? Now it's important, I can only do this because both of these things are both defined already, right? I can't set the target M up here, right? Because the code flow goes from top to bottom, right? So at this point, M has not been defined, right? So I have to define all my objects, or instantiate all my objects first, right? And then I can set targets. And these two wizards are going to fight each other, so we set the targets equal to each other, and then we can kind of print them out, right? Which is what we have. And we see that unable to set target went away because we're using good data. All right, so now what we want to do is we want to start a fight. We'll start the battle. All right, so if we start this battle, we need some way of attacking. All right, so we need some method, define strike target. Okay, so this is one wizard, self. That wizard is going to be doing the striking. So if I say g.strike target, G is the one attacking, and the target is should already be set here. Right? But we need to check that. So if not self.target. Okay, so this is a short way, sorry, that should be if. This is a short way of saying if nothing is stored here. It's like saying if this does not evaluate to false. So the Boolean value of none is false. Python 3. If I were to convert none to bool, that would be false. If I were to convert the empty string to bool, that would be false. A 0 to bool would be false. If I were to convert a list to bool, it would be false because that's an empty list. A list with one element is true. Okay, so whenever you have an if statement, Python, if it's not a Boolean value, Python tries to convert it to one. Right, so that's why we can do something like this, self.target. So it tries to convert that to a Boolean value, and if it does, and it's none, this would be false. So if not false is true. So basically it's saying if we do not have anything set on target, then we want to return, because we can't strike anything. We can print a message. We'll say no target, unable to strike, and then we'll return. Right, so we could test that. We have to go, we'll comment out this target. We don't need these lines anymore. We'll say Gandalf didn't target anyone, and we'll print, or we'll say Gandalf.strike target. Okay, so here we commented out where we set our target. So now we have no target, and we're going to try to strike our target. So this is where we should see the message. Oops, fix it. No target, unable to strike. Right? Now, if I uncomment that, now he does have a target. So we need to define what we do if we actually do have a target. So if we do have a target, what we want to do is remove some health from that target. So this is going to be some wizard W, right? Self.target. It's important that you understand that this is a wizard object. This, in terms of Python, this expression evaluates to the wizard object that we passed in down here. Okay, so it's going to have a name, right? It's going to have health. It's going to have all those things. So what we want to do is we want to remove some of its health. So we're going to say self.target.health minus equals. So subtract whatever health from whatever health it already has. We're going to subtract this value. And what value do we subtract, right? Well, it's our damage. How much damage do we do? That's what gets subtracted from our target's health. So self.attack power. All right. Now, most of the time in these types of games, as soon as you attack somebody, you might see something print to the console. Print. We have a format string, and we'll say self.name. So this is the wizard. This wizard, right? The one doing the attacking is self. The one being attacked is self.target. Okay, so this wizard's name struck. Let's see. This is self.target.name. Right. So we know that this is a wizard, right? Or that we do have a target. So we're going to assume it's a wizard. Realistically, we should probably check to make sure it is with the, if type is wizard. But it's good enough for now. So if our wizard doing the attacking name struck this target wizard name for self.attack power points of damage, leaving, and then this is, we want to list out the health of the player we just attacked. So self.target, right? Doesn't like that. Health. Leaving self.target.health. Okay. So all we did was subtract whatever our attack power was from the wizard we were targeting. We subtracted that amount from their health. And then we printed out some information about that transaction. So Gandalf struck Merlin for 30 points of damage, leaving 61 health. Right, so apparently he had 91 health, right? So we struck him for 30 points, and that leaves 61. All right, now we can also say Merlin dot strike target. All right, so Merlin hits a little bit harder, but Gandalf has more health. Right? So what we can do is kind of do a loop here. Now, obviously, this would be much different in a real game, but the main purpose of this is to sort of show you how classes work, right? And it's something that's a little bit fun and interesting. So we can have a loop here that is while true, we can do these things. We can have them strike each other, right? Now, this is going to be an infinite loop at this point, right? Because while true, the condition that the loop executes is set to a Boolean literal of true. So it's never going to stop unless we use our break keyword, right? But let's just run this as an infinite loop anyway and see what happens. All right, so we see big negative numbers here, right? So Control-C breaks us out of the loop. But negative health numbers don't make any sense, right? When you hit 0, you're supposedly should have perished, right? So what we need to do is we need to say somewhere in here, if either of our wizards, their health is less than 0, then we'll break out of the loop, right? So if g.health is less than or equal to 0, or if m.health is less than or equal to 0, we will break out of our loop, and then we will check if g.health is less than or equal to 0. We'll print something out like Gandalf perished. Right, but then we'll do the same thing if Merlin dies. Oops. So if Merlin's health is less than or equal to 0, then Merlin perished at the hands of Gandalf. Alright, so this should break us out eventually, because we're subtracting and subtracting and subtracting health. At some point, one of our two characters should go negative. Alright, so Gandalf strikes for 30, leaving 61, 35 for 65, 31, 31, 1 health, and then negative 5. Alright, so negative 5 doesn't really make sense. So what we might say here, we might change this a little bit, and if it's negative, we'll just set it equal to 0, right? And then we might say that he died. But here, it says Gandalf perished at the hands of Merlin. So Gandalf was the one who was struck. Merlin struck Gandalf and cleared out all of his health, and so he perished. He died, right? So this is something that you see all the time in different video games. Even if you don't like video games, you're not a big video game person, you're probably going to have run across this style of video game at some point. So let's fix up that last thing before we bring this to a close. We have strike target. So here we subtract from the health. So self.target is the wizard we're targeting. We subtract a certain amount of health. If self.target's health is less than 0, we're just going to set it to 0. Oops, self. Here we go. We're going to set self.target.health equal to 0, because we never want it to go below 0, because that doesn't make any sense. Right? So we might want to make one other change here at a period, but if the health is 0, instead of saying leaving a certain amount of health, we'll say killing him, or yeah, ending his life, or ending, yeah, something like that, right? So we don't necessarily want to do him or her, because then we have to know the sex of the wizard, right? So that's a little, right? That's why in video games you select the gender and all that stuff, so that you can use the right pronouns and all that stuff, right? So leaving some health, we can say the finisher text is going to be this format string, and we could say if self.target.health equals 0, we'll change the finisher text, and we'll say that we'll not worry about the gender thing for right now. We'll just say wizards. We'll assume wizards are men and witches are women, or something like that. I don't know. So finisher text, killing him. Okay, so no periods on either one, because we have the period here. So basically, depending on if their target health is 0 or not, if it's not 0, it's leaving some health. And if it is 0, then we say killing him. Or here we go. We'll say killing the target. All right. So we've run this again. And so we've dealt with, you can never have negative health anymore, and also we've dealt with the situation where at the end it says Merlin struck Gandalf for 35 points of damage, killing the target. Right? And then Gandalf perished at the hands of Merlin. Right, so this is a really simple example. This is not exactly how things would work in a real game, but it gives you a sense of kind of how those things can be coded up, a general idea of basic classes. Right? We didn't use any inheritance or anything fancy. This is just a really standard class. The whole point of this is to illustrate a basic concept of classes and attaching data to objects. And we could make hundreds of these objects. We could have hundreds of wizards, and we could figure out a way to make them battle and give them different attributes and different points. And as we change those attributes, we could see which one would win. We could have attack speed, and someone who has a low attack power but has a really high attack speed might do really good. And we could have armor absorb some of the damage, and this would give us an idea of sort of character classes and character traits and different things. We could have potions that they could drink and that would increase their health, or make the effects of attack go down, or something like that, right? So different buffs that you could put. But you can kind of see, you get a sense of how all of this could potentially work. You also get a sense of how quickly you develop a lot of code for relatively simple ideas, right? We only have a few things here. Name, which is pretty simple, and we have like two main attributes. We have health and attack power, right? And then this idea of a target. And that's all we have. And then we had to add a bunch of functionality around that, right? And before you know it, this sort of becomes a lot of code to do something relatively simple, right? Or what seems simple, something that we see all the time and we take for granted, right? So this is just a simple example of classes, sort of video game analogy. So hopefully that you learned something and that was enjoyable.